Today we're going to talk about the tangent function, so I'm just going to do a couple problems from the worksheet. The first one here is number 9. The directions tell us to identify the period and tell where the asymptotes are in the interval from 0 to 2 pi. Now I'm going to do that, but I'm also going to graph the function so that'll give you an idea of how to do problems 10 through 27 where you have to sketch 2 cycles of the graph. So to find the period, all I did was take pi divided by b, and according to my equation, b is pi. So pi divided by pi is just 1. So the period is 1. The asymptotes, you always know that the cycle ends from negative pi over 2b to pi over 2b, so that's also where my asymptotes are going to be. So since b is pi, I take negative pi over 2 pi, and pi divided by pi is just 1, so I get negative 1/2. But again, my interval has to be from 0 to 2 pi. So the positive of that is 1/2, because that's pi over 2b, remember? It's 1/2, so that's where that comes from. Now, since we want the interval from 0 to 2 pi is equivalent to 6.28. So I have to keep figuring out what all my asymptotes are until I get to 6.28. So I know one of them's at 1/2. Since my period is 1, that means my cycle starts and ends, and then there's a difference of 1 in between. So if I am at 1/2, if my period's a 1, I'm going to add 1 to this to get to the other asymptote. So 1/2 plus 1 is 3/2, plus another one is 5/2, plus another one is 7/2, plus another one is 9/2. So notice again, I'm just adding 1. I'm just adding what the length of the period is to get from one asymptote to the other asymptote. Alright, now if I wanted to graph this, I'm not done here. You'd have to keep going until you got up to around there. So you have lots of asymptotes here. But I'm just going to graph this now. To graph it, I pick points I want for my radians. And again, I just picked pi over 4 because that's the increments I like to count by. And I wrote down what the decimal equivalent is so that when I graph my period and my asymptotes here, I have an idea of what numbers I'm looking for. So at 0, I'm at 0. Pi over 4, I'm at negative 0.4. I'm right around here. And then at pi over 2, at negative 2.21. 3 pi over 4 is at 1.03. Pi is at 0.24. 5 pi is negative 0.12. 3 pi over 2 is down here. 7 pi over 4 is way up at 71. It jumps way up there and then drops back down to 0.62 on the 2 pi. Which is really strange that it jumps way up there, but that is the number the calculator told me. Now, my asymptotes here, the reason I have them written out is so that I can put them on the graph here. So I have one asymptote at 1/2. So since pi over 4 is 0.79, 1/2 is going to be right about here. And again, I have a period of 1, so my next one is at 3/2. It's over here. And then again. And another one. So my asymptotes are all really, really close together because my period is very short. And just like we talked with the cosine graph, we talked about how the maximum and the minimum were different, so we're missing pieces. So this tangent is going to look something like this. And we're going to go through those circles a little bit, but that's not the full story, remember. So we have a rough sketch of something like this. Alright, let's do number 30. The directions for number 30 say to identify the period of each tangent function. Well, that's easy enough. Period is always where a cycle starts and finishes. So if we look at this graph, we're starting here, and we go to here. And also a cycle is always from one asymptote to the other, which is also what our period is going to be. So I end at 3 pi, and I finish at pi, so 3 pi minus pi is 2 pi. So my period is 2 pi.